Welcome to the fascinating world of mechanical drawings. These drawings are the blueprints of engineering, communicating complex designs with precision. But have you ever stopped to consider the silent language they speak, the language of lines? Each line type, from solid to dashed, carries specific meaning crucial for accurate interpretation. Imagine a mechanical drawing without standardized line types, a chaotic jumble of lines with no clear meaning. It would be nearly impossible to decipher. Thankfully, we have a system of line types that brings order to this potential chaos. Different line weights and patterns convey crucial information about hidden features, centers, movement and more, making complex designs instantly understandable. Hidden lines, depicted as short, evenly spaced dashes, are the secret revealers of mechanical drawings. They give us X-ray vision, allowing us to see edges and surfaces hidden from plain view. Imagine a solid block with a cylindrical hole drilled through it. On a drawing, the hidden lines would represent the circular outline of the hole on the far side of the block, invisible to the naked eye. Without hidden lines, we'd be left guessing about the internal structure of objects. They are essential for representing the complete geometry of a part, even the parts we can't directly see. Section 3, the heart of the matter: center lines and symmetry. Center lines, easily recognizable by their long, short, long dash pattern, are the unsung heroes of balance and precision. They mark the center axis of symmetrical objects and features. Think of a shaft. A center line running along its length instantly tells us where its rotational axis lies. Center lines are crucial for aligning components, drilling holes at precise locations, and understanding the symmetrical relationships within a design. Section 4. Ghosts of design, phantom lines and their applications. Phantom lines, with their long, short, short, long dash pattern, are like ghosts of designs past, present and future. They represent features that are not directly part of the object but are essential for understanding its function. This could include alternate positions. Imagine a door on a machine casing. Phantom lines can show the door in both its open and closed positions. Adjacent parts. They can depict the position of a component that interfaces with the main object, even if that component is not shown in detail. Repeated features. For objects with repeating patterns, phantom lines can indicate the extent of the pattern without drawing each element. By subtly conveying this additional information, phantom lines prevent clutter and ensure clarity in complex drawings. Section 5. Lines of communication, a recap. We've journeyed through the world of hidden lines, center lines and phantom lines, each with its unique role in the language of mechanical drawings. Hidden lines reveal the unseen, center lines establish balance, and phantom lines provide context. They are the unsung heroes of engineering communication, ensuring clarity and precision in conveying complex designs. Conclusion: mastering the art of line types. As we conclude our exploration, let's appreciate the power of these seemingly simple line types. They are fundamental to creating and interpreting mechanical drawings, transforming abstract ideas into concrete designs. So the next time you encounter a mechanical drawing, take a moment to appreciate the silent language of lines. Which line type do you find most critical, and why? Mastering these concepts is a valuable asset for anyone involved in the world of engineering and design.